Dude's channel. I'm going to try something new today, and that's mostly because I failed to record sound while I recorded this video. So I'm going to try talking over it as we play through this video. There's going to be some interesting footage per se, mostly because the CR-10 is massive printer, and the only space I had for it at this time of recording was on the floor. So please bear with me, and I hope to take you through a interesting journey of working on this. Alright, I guess let's just go ahead and jump right on in. The main reason why we're here working on this CR-10 is because I got it used from another fella, and it came with a lot of extra goodies that I want to make use of, but at the same time I really want to throw in a bunch of new components and make this a really solid machine. So one of the big things we have here that I'm going to add into this machine is putting this Samara direct drive extruder on, and I'm going to do this as a direct drive extruder itself, not as a Bowden system, and that way I don't have to worry about any pushing through a really long Bowden tube. And at some point I think it'd be nice to decliperize a lot of my machines and really try to push them to the maximum possible speed they're able to do. And I don't want to come back to using, Bowden capabilities, which there's nothing really wrong with Bowden, but it's something that if I can go direct drive with parts I already have, and I already have a spare Amera direct drive extruder on hand, so there's no real point in me doing anything other than that, or trying to modify or go out and buy a different system. For anyone else, it might be a different story. For me, this is what I'm going to do, and to make this work, I'm going to end up doing a number of custom options, but really that's more of a part 2 to this. But for now, I think we'll go ahead and focus on fixing this machine up to make sure I can make it square and really take it to the notch that it'll be able to handle this direct drive system and keep tolerance fairly well, at least. To get this started, we're going to look at this first z-axis and how Creality builds on their x-axis to their z-axis. And it's a pretty interesting carriage system that they use 3 wheels on either side in order to basically create a triangle, which is a very stable shape. But the thing about a triangle and it as a stable shape is if you try to do 2 triangles and a cross beam and stick them in a rectangle, it doesn't always quite work. But we'll get around to that. So this plate is going to be our major issue for adjustability, because I want to be able to adjust that center x-axis to be parallel to the build plate itself, and the way that the triangle piece is held on, it's actually bolted through each wheel on the 3 corners, and one of them's a tensioning wheel. If you're not familiar with the system, if you are, you know exactly what I'm talking about. But the one closest to that x-axis in the center is the one that is adjustable, and it's the one that we're going to want to focus on first for making sure that this particular carriage is in its proper place. Now, the tricky part becomes the heads for the screws that go into this x-axis to mount it to the carriage and hold it square to that carriage are on the opposite side of the Z rail on this side. So it poses an issue where you can't loosen and then retighten if you need to square up anything or adjust the angle that it's mounted to this particular carriage. And this is very important because a person actually has to adjust the angle of that x-axis according to the carriage if they want to truly square in this printer. So with that in mind, we're going to look into an option of how do we go about adjusting those screws while keeping the carriage on the printer itself. There's not much point in taking the carriage off, trying to adjust it, put it back on. That's just a whole lot of hassle. So if we can figure out a way to adjust it with the carriage in place, then I think we'll have a pretty fantastic setup. And note, there's already 2 holes in the carriage itself, and I thought that they were going to line up. Little heads up, they don't. But the key here is going to be making it possible to basically reach through the z-axis to the x-axis at some location where we can adjust to a squareness. I think it's the best way to put it. Now, this does help where the printer has dual seats, because that way we can go ahead and once it's loose, run it all the way down and tram in the system, or make sure that that x-axis is parallel to the build plate. And once we have it trammed, we can turn on the printer and it will engage the servos, which will lock them in sync to each other. And then all I have to do is raise the z-axis to wherever the adjustment points are. And as you can see here, I'm kind of thinking about putting some adjustment points up close to the top, and that's where I end up putting them. And so all a person would have to do is drive that x-axis to the top, or increase the z height up until a certain number where I can reach through both that carriage and the z-axis there to reach the pass-through nuts that bolt that carriage onto the x-axis. And we'll go ahead and skip to that operation now. So what we're going to do here is just go ahead and use a speed square, since it's got the little catch on the side, in order to both do a measurement down from the top, but then also make sure that the holes that I drill are going to be in line with the x-axis, basically square with that z-axis. And then I'm just going to go ahead and drill straight through the z-axis. I'll start with this one, and then once I have a spot marked, I'll actually leave the drill bit in the hole that I'm drilling right now, and then more or less run the top of that speed square right up to the drill bit, hold the speed square still, and then pull the drill bit out and go ahead and make my next drill, make my next hole. And that will make sure that those 2 holes are square, I guess 90 degrees to the vertical z-axis, and that'll be as good as you can get without just eyeballing it, in order to line it up with where the x-axis should be if everything comes out square as intended. Now, I think I ended up using Imperial drill bits for this. This slot ended up being pretty close to a quarter, and I was like, yeah, that's good enough. And so now, because I already have the pre-drill in place, I can just go ahead and slap in the 1/4 inch drill bit and fly through it real quick. Yeah, it's just a matter of drilling through this. First one's square, and the second one actually ends up being at an angle, but that's because of Creality's placement of the second screw, which I do prefer the 2 screws that hold the carriage onto the x-axis to be pretty far apart, just for more stability. But that also, they don't line up with the slots in the extruded aluminum, so it makes it a little bit more tricky to actually go ahead and accommodate. So what ends up happening is I'll drill out the side closest to the outside edge of the printer, and I will angle, I guess, the tip of the drill bit outwards towards the edge of the carriage, and the drill side of the drill bit inwards towards the inside of the printer, and that will give it's pretty close to, I would say, a 30 or 40 degree angle by the time I get done drilling it out. And that is so that I can actually reach in with the Allen wrench, which has a ball head to it, and just barely get a hold of that second screw, even though it's at an angle. Now the real fun part here is I also get to try to line up this carriage plate, and not gonna lie, I pretty much just free-handed winged this shot, and it worked out way better than anticipated. The nice part is I can just go ahead and line this up, and that second Z-axis screw really comes in handy, just holding it in place. But you can see how much wobble there is with me moving the side without the Z screw in place. It just got at least an inch, probably close to 30 millimeters of free play in it. With that, and I'm pretty sure I already tensioned the side with the Z screw still there, and it still has that much play from the torque and using plastic wheels and the deformation of the materials involved. And that's where making sure that this is square and making sure that there's the ability to square things in the future really becomes important. And so now you can see me twisting that drill, and it uses the side of the drill bit to cut, but it's fine. It's aluminum, extruded aluminum, so it's just going to cut right through it without much issue at all. And then I'm just going to eyeball this, like I said. And I think I got really lucky that this plate and where these holes ended up, not only did the hole I make in the outer plate line up with the angled hole that I had drilled into the extruded aluminum, but also something I didn't quite think about whenever I was putting this together is I have to be able to reach around a Z-axis screw unless I want to take that screw out, which there's no point in taking the screw out if I'm trying to make this square. So I have to be able to reach around that screw in order to, and this is the Z screw, in order to tighten the X-axis carriage screw. It rubs whenever I go ahead and stick the Allen key in order to do the tightening or loosening as necessary, but it is in place. Right here, I'm just going ahead and cleaning up the aluminum. The aluminum is softer than the steel of the knife, so it's not too hard. I'm just real basic deburring, being pretty careful about it. I think that it will probably dull your knife a little bit if you try this. The goal here is to make sure there's nothing that's going to catch on that carriage or on anyone who grabs the printer to move it around, or any various loose hanging items, especially right now while it's in an exposed place. But even just a hand grasping the rail, you don't want to cut your hand on a bit of aluminum sticking out. So now I'm sticking that Allen key in, testing to make sure I can find the socket head part of that screw with the Allen key, and that it'll fit. And I do have success. It's tricky, it's kind of questionable, but it is there. And now I'm eyeballing, giving a general idea. So that plate sits off of the extruded aluminum just a little bit, and so I, in my mind's eye, kind of playing a game of billiards. All right, how far off do I need to be in order to line up my stick after I make a hole? So I drill straight through at first, and I move this plate to a more steady spot. I believe I set it on a storage tray in order to have 3 sides and an empty hole in the middle to provide steady, but no, that didn't work. So I moved it to the extruded aluminum. It's already gone that bit. I know how wide it is because it's already fit into the rail portion of the extruded aluminum, and so I can just drill right into that. The plate is going to be very steady whenever I'm drilling, and it's just a matter of making sure that the plate doesn't catch in the drill bit too much and pull it out of my hands. But that is the beauty of using an impact to do drilling instead of an actual drill. If there's resistance, it will generally not just go hog wild and torque it out of your fingers instead of just ratchet in place, which it doesn't feel great, but it also doesn't remove fingers, thankfully. And of course, using a low input, trigger control goes a long ways. Again, I'm testing. Lots of dry runs to make sure this works is key to success, and it is not easy by any means to make sure that I end up hitting that the head of the screw with the Allen key and that plate in place, but it is possible, and it shouldn't be something that gets adjusted too often. As long as once you move the printer to a set location, do it once there, it'll be pretty well set for life. And even in general, it should be set without too much concern. But I will note this printer is very flimsy, and that's mostly because it's large and uses the same design as much smaller printers, and the torque that you end up being able to exert on the same parts is immense due to that the lever arm length is less force to get the same amount of torque or greater torque. So this ends up being a pretty flimsy printer if you accidentally move it the wrong way. It looks like I'm set there, and I'm going to get back to assembly. It's just a normal carriage. I'll check for square here, but the real magic will happen once we get down. We bring that x-axis down to essentially a zero level and install the second Z screw and check to make sure that the x-axis is parallel to the bed. I think I'm just doing a quick check to make sure that the bed is more or less square to the y-axis, but there's not much a person can do about that. And then here I'm doing a squareness between the z-axis and where the bed should be. And as I mentioned, this frame is rather weak. Yeah, it's not even close. So this is going to be a fun one where instead of trying to loosen anything, I'm just going to straight up torque it. Just chiropractor. Move it into place. And it's shouldn't work, but it does. Maybe a little bit more oomph. The only reason why this works is because everything is a parallelogram right now. A very stiff one trying to be square, but it is nonetheless parallelogram. So if I can give it some good massaging, the Z extruded aluminum bars are going to stay parallel. And then effectively that plate and the x-axis and the top bar that holds the Z bars the right distance apart, those all should theoretically stay parallel. And so once I have this build plate square with the z-axis, I'll be very confident in being able to make very tall and very square parts upon getting this printer to run. So it looks like I am set here with having the z-axis square with where the x-axis is going to run. Next step is to go ahead and install that z-axis again, and we'll just go ahead and jump into when that is already installed again. Alright, z-axis is finally assembled. Both sides are looking alike, and the nice thing is we might actually not need to touch the left side. Here on the right side, we can actually see the holes right next to the anti-backlash nuts, and then right next to the screw, you can see it barely had a hole there. And that will go ahead and line up to the hole right next to the anti-backlash nut. Whenever the z-axis is raised up electronically, that's going to be our adjustment point Also, as a part of the assembly, I did go ahead and tighten the what you can see now as the leftmost nut on the carriage. That is the, like, on the inside there's a offset, it's a cam actually, and so you turn it and it will cam the wheel in closer, or turn it the opposite direction and it will cam the wheel away from the vertical extruded aluminum slot, and that allows you to tighten and or loosen the Z carriage on that extruded aluminum. The goal being of having that tight with the x-axis loose, of course, is that now we know that carriage is going to be solidly in place. We can go ahead and set the other side, which is actually easier. We don't have to do any drilling. The points of which it mounts to the x-axis are indeed accessible without needing to do any additional maintenance, and that allows us to now have all potential fastening points available to us whenever we need to square up this x-axis again. This wraps up everything I want to cover today in this video. If you have any questions, feel free to reach out in the comments below. I'm more than happy to help anyone who's interested in making this modification on their own printer. Other than that, this is Dr. Do. Like, subscribe. As always, Tricky's my business. I'll see you next time.